If you're new to this channel, you may consider subscribing and hit the bell icon so that you continue to receive the updates. Also, after watching this video, you may want to refer to some of the playlists that we have created for people who are interested in in-depth knowledge. Please share it with all others who might benefit. Let's get started. This perhaps is going to be the simplest tutorial which explains the concept of gradient descent, at least for the beginners. Let's start off by playing a game. Let's say we have a piece of paper that we've crumpled and it has got a lot of peaks and troughs in it. It's in a multi-dimensional space. We are looking at it like this. And we are at this location. So there's a starting point for the game where we are right now. Because we can't have a 360 view of this paper, for ease, we have taken a two-dimensional projection of it. So in a two-dimensional space, this is how it looks like. That's like right from the top, we are looking at it. And this is the starting point. Now, the game is simple. You need to score the lowest here to be able to win the game. And when do you score the lowest? When you touch the bottommost points on the surface. These points here are represented by these dark patches. And you can see there's a color grid given. So we have to score the lowest to be able to win this game. To be able to move here, we've been given two sliders. One is called a weight, other is called a bias. Now, by just looking at it, I think you'll say this is pure common sense. If you want me to make it to any of these four patches, I can always do it by adjusting these two sliders. For example, right now, we need to move right on the x-axis and move a little downwards on the y-axis to be able to make it to this patch. Let's try that. So we'll try to adjust this weight. We'll move to the right a little bit and see how we are heading. Okay, so we're almost there. And I can move it a little further as well. Maybe this much would be fine. And now, I move it a little bit downwards. Not much, I can move it a little bit downwards and I'll be just fine with that. See, we just made it. It's so simple. Now imagine somebody says that you want to make it to this point. That's again not very difficult. We can move a little to the right and a little bit downwards, right? So if I move a little more to the right, I'll have to increase the values on the x-axis, which are the weight values. And I think we're there. And if I have to move downwards, I have to reduce the bias values here. So I'll do that. I moved a little bit, but probably I need to move a little more. And maybe this would do the job. We're almost there. Great. So it's so simple for us, isn't it? It is so simple for us because we can see and we have a gift which is known as the human intelligence. But imagine if we were to do this task with our eyes closed. Imagine closing your eyes, you're blindfolded. Somebody points you to the sliders. You know where the sliders are, but you can't see them. Somebody's assisting you. This person is giving you directions to move right, to move left, to move up or down. Somebody is giving you feedback to do that, but you can't see that. Trust me, the same game that we just played was so simple, will become a little more complex for us. And why did I talk about being blindfolded? Because when it comes to machines and they're trying to solve these problems, they really can't see the way we see things. And this friend of yours who was kind of guiding you with the directions earlier is, in case of a machine, the gradient descent algorithm. So this is a simple analogy. Now let's get started with the formal terminology of gradient descent. And by the end of this tutorial, you would have completely decoded it. So gradient descent is an optimization algorithm used to minimize the loss. Now, what is optimization? You want to get the best results targeting an objective. You have a goal in mind and you want to get the best results. Just like in our case, we wanted to land at any of those four spots to score the lowest in order to win the game. Now, what is this loss? So generally, loss could be a function that talks about the difference between the actual and predicted values. And there are many loss functions. But for ease, for simplicity, we are taking a very common loss function, which is the squared error loss. The difference between the actual and the predicted values, squared and added up for all the observations, and we are taking an average of it. Let's say this is a loss right now. Why do we want to minimize? Because while making predictions, while working with different machine learning algorithms or deep learning algorithms, we want to ensure that our predictions are as close to the actual values as possible. So in this example, imagine this crumpled paper is actually the loss function, and we want to figure out the minimum value of loss. Fine, we understand the loss. Now, let's spend a little more time to understand what is a gradient and why do we use descent. Before we jump onto gradient, you'd realize that commonly people use a lot of terms interchangeably. They'll at times say slope, at times they'll say derivative, at times they'll say gradient. We all do that. But there's a subtle difference between these. Let's understand that closely. So when we talk about a slope, it's given by a formula like this, delta y divided by delta x. When we talk about a derivative, it's something to do with calculus, and it's a different formula. But when we talk about a gradient, it is altogether different. Gradient is a vector, so partial derivatives in a multi-dimensional space form the gradient. Derivative is for a single variable, but when we are dealing with multiple variables, we are talking about a gradient. Let's have a closer look at these points. Let's say we have a line which passes through these 2 points, x1, y1 and x2, y2. Now we want to find out the slope. So what is the slope here? Slope is simply calculated by delta y, which is nothing but the difference between y2 minus y1, this vertical difference and this horizontal difference. If you put these values here, we'll get the slope. Now, slope is a term generally used in context of a line. When we are talking about slope, we are referring to a line most of the times. But when we are talking about a curve or a different kind of a shape, you can realize that it would not have the same slope everywhere because it's not a line, it's a curve. So let's say we have a point here, this red point here is a point on this curve, and we want to find out a tangent for this. So tangent is a line which touches the curve exactly at one point. Now imagine zooming in. Let's say we move a minuscule distance h on the x-axis. What will be the change in the value of the curve? Imagine if the curve equation is y is equal to fx. If we move from x to x plus h, what will be the change in the value of y? It's an extension of what we discussed just some time back. Imagine if we were at x and we moved a distance h on the x-axis. So now how much have we moved? x2 minus x1, just the way it is written here. This will be h in our case. And as a result of this, what will be the movement in the value of y? That will become x plus h. If this function is y is equal to fx, originally it was x, and now that we've moved, it'll be y is equal to f of x plus h. You're just taking the difference between y2 and y1 and x2 and x1, assuming that this movement is minuscule. In case of a line, this movement would not make a difference. It could be a much bigger movement. You will continue to maintain that slope throughout. But in case of a curve, things would change because we are talking about a tangent, which will be a different tangent if you look at another point. That's why we are talking about moving a minuscule distance, and that's called a derivative. Now, when we talk about a multi-dimensional space, we will be taking partial derivatives with respect to every variable. A multi-dimensional space means you have multiple variables. So you have to take partial derivative with respect to each variable, and what you get is called a gradient. So gradient is essentially a vector, and it's applicable for a multi-dimensional scenario. If you talk about a single variable, it's called a derivative. How does it look like? It will be similar to this. We can make it more complex, but it will be very difficult to visualize it then. So imagine the multi-dimensional example that you were talking about some time back. It's like the crumpled paper that we talked about. It's something similar to that. So I hope you get the idea about what is gradient. Gradient is not to be confused with slope and derivative all the time, though we tend to use these terms interchangeably, but might not be a good idea in a formal setup. Now let's talk about the idea of descent.